I'm going to differentiate this. So my x is 3t squared plus 5t plus 7. So I want to differentiate x with respect to t. So I'm going to go here. 3 is a constant. I'm going to leave it alone. I'm going to go to the t and differentiate it. How do you differentiate the t? You take the power down, which is in this case 2. You write t, and then the power minus 1. 2 minus 1 is 1. Good? Plus 5. You leave it alone, and then you go to the power. What is the power of t in this case? 1. So you write 1, you write t, and then 1 minus 1, right? Plus 7. Does it have any t? So when you differentiate it with respect to t, it doesn't change, which means it has no change. Good? No t, no change. Now, t to the power 0 is?
1.
Anything to the power 0 is 1. So this whole thing just disappears. Cool? And that would leave us with what? 3 times 2 is? 6t plus 1. So 2 times 3 is 6t. 1 just 5, no t, gives you 0. And that would give me my velocity. Now at t equals 2 seconds, I'm just going to substitute 2 plus 5, which gives me what? Cool? How is that? Good? Not good? Finally, can you find the acceleration at t equals 5 seconds? Can we find the acceleration at t equals 5 seconds? And the relation between a and x, or a and v. So we could write a as the change in v with respect to t, or we could write a as the change in x with respect to t. Meaning you have to differentiate it one time, then differentiate it a second time. Or you could take v and differentiate it another time. Good? So if I want to differentiate v, what is v? We just found what v is. v is 6t plus 5. So a would equal, this is to the power 1. 1 times 6 is? So it's going to be 6 times 1, t to 1 minus 1. And does this have any t in it? No. So that's 0, and that would give me what? 6. And at t equals 5 seconds, what's the acceleration? 6. Acceleration is always going to be the same, 6. Just in this example. Not always, just in that example. Meaning, my speed is going to increase by 6 meters a second every second. So at t equals 0, my speed is 0. At t equals 1 second, my speed is 6. At t equals 2 seconds, my speed is 12, 3, 18, 24, 30, 36, 42, and so on. Cool? I am always speeding up. How you guys feel about this? Okay. Now, acceleration is not always constant. It could vary. But let's take the case if the acceleration is always the same. Meaning the acceleration is always 6, or 9.8, or 2, or 0.31. Whatever. So what would happen if my acceleration or my acceleration is constant? But here's an interesting question. What is my acceleration if my v is constant? What is it? What? So this is what acceleration is. We mix a lot acceleration and velocity. Remember, if you're set your cruise control and you're going in a straight line, your speed is always going to be the same. Your direction is always going to be the same. Are you speeding up?
No.
Are you slowing down?
No.
That's what acceleration is. Are you speeding up or slowing down? If you're not speeding up or slowing down, i.e. going with constant velocity, your acceleration is 0. So remember, a car going with constant acceleration, so a car is going with constant velocity. Do you know what acceleration?
Yep.
So if you ever seen this, constant velocity, immediately something should flash in the back of your mind. Acceleration is 0. Now, let's take to this case. What happens if A is not 0, constant, like 6 or 2? If that is the case, you will find that the average acceleration equals the instantaneous acceleration. Just to show an example, let's assume my acceleration A is 3. So if your velocity 1 at t equals 0 was 5 meters a second, then at t equals 1, your velocity equals what? Anybody? If we started with 5 meters per second and you're accelerating at 3 meters per second squared, after 1 second, what is your velocity? 8. Yeah. And at t equals 2 seconds, your velocity is going to be, so this is v2, v3 is going to be what? 11. I'm just going to do one more. And at t equals 3, your velocity, which is v4, is going to be what? 14 meters per second. Okay, that is my average acceleration.
Meters per second squared.
What is it?
3 meters per second squared.
3 meters per second squared. How did I know that?
Because you gave it to us.
No, let's assume you don't know this. Can you find the average? What's the definition? It's delta V over delta T, which would be what? Right? 14 minus 5, right? Divided by the time. What is the time? That's not what I want to do. Okay, so if I wanted to find my what do I want to find? What do I want to find? Let's assume I want to find the acceleration between these 2 points. What is it?
3.
It's going to be delta, whatever it is, delta V, delta T. And this is going to be 5 or 8 minus 5 divided by 1 minus 0, which gives me 3. And if I want to find it between these 2 points, what is it?
11 minus 8.
11 minus 8, which is 3, divided by 1, which is again
3.
3. And if I want to find it between last one and the first one, which gives me
14 minus
3, right? So based on that, you could see that my instantaneous acceleration, A, average, should equal. Is that good?
11. Yes.
If I say so, right?
You're the boss.
Well, good. So based on that, from this, the follows, I want you to put a note on your notebook